So now we are going to discuss about the deadlock avoidance. So here we need to consider that the thread first itself the thread declares the maximum number of resources of each type it may need for its to complete its execution. That has to be informed the starting itself. There are two types of algorithm in deadlock avoidance. One is the safe state algorithm. The second one is the resource allocation graph algorithm. So we discussed these two algorithms. The first one is the safe state algorithm. So if the system is in safe state, there exists a safe sequence. So if it is the safe sequence, then the system is in a safe state. Okay. So consider so the T1, T2, etc. The Tn. If this is this might be a safe sequence. So we see one example for this. Consider a system with 12 resources and 3 threads. So the current need of the 3 threads are that is thread 0 is 5. The current need of the T1 is 2. Current need of the T2 is 2. Okay. So out of the 12 resources, so it requires the 9. Okay. So 12 minus 9, there are 3 free resources are available. Okay. Now the maximum need, this is the currently using. Okay. Now consider that so to complete the execution, the thread T0 needs, so the maximum need is 10, already allocated is 5, the remaining 5 it needs. But we have only that 3 resources. So the T0 cannot start its execution as that requested 5 resources are not available. Now consider that T1. So already 2 resources have been allocated, maximum need is 4. So that 4 minus 2 is 2. So the T1 needs only the 2 resources. So we have 3 resources. So we can allocate from the 3, we can allocate 2 resources. So T1 can start its execution and complete. After, so available is 2. We have allocated T1 is 2. So 1 resources might be there. After T1 completes, we get 4 resources. Now 5 resources are available. Okay, so now check with T2. So maximum need is 7. Already now it have 2 resources. So 9 minus 2. It needs 7 resources. But we don't have a 7 resources. We have only that 5 resources. So again go and check with T0. The already 5 has been allocated. So it needs remaining 5. So we have a 5 resources. So T0 can start its execution and complete. After T0 completes, the already allocated 5 resources also has been released. So totally now we have a 10 resources. So by what is the now unexecuted uncompleted thread is T2. The need of that T2 is 7. So from the 10 we can allocate 7 resources. So T2 can start its execution and complete. After T2 completes, it released that 7 and plus this 2. So totally we have a 12 resources. Okay, so this is the safe sequence for this. Now consider that there is at time T1, the thread T2 requests one more resources. So the maximum need of that T2 has been increased. Okay. So already allocated. It means that already allocated. So consider that the current already allocated for the T2 becomes 3. Now we cannot execute that. So that system might goes to the unsafe state. Okay. So in any order you can complete the execution of threads, but none of all the threads needs to complete its execution in any sequence. If it not any one of the threads not even complete its execution, then the system is not there in the safe state. Next we see the resource allocation graph algorithm. For in that resource allocation graph, we have one more edge called as climb edge. Here, Ti Tj. It means that here we have it is a dashed line. Okay. So it means that it indicates that Ti may request to resource Rj at some time in future. Okay, it's not the requested, it is a claimed edge. In future, it may use the resource Rj. So before thread Ti start its execution, all its claim edge must be already appear in the resource allocation graph. Consider this example. In future, the thread T1 may need that resource R2. Like that, the thread T2 also may need the resource R2. These two edges are climb edge. Okay. So before in the resource allocation graph itself, we need to keep that climb edge. Okay. So for example, at some point of time, the resource, the thread T2 requires the resource R2 and it has been assigned. Now consider that there will be a cycle formed here. So it is an unsafe state. So whenever that it leads to an unsafe state, this resource cannot be allocated as it leads to unsafe state. The R2 cannot be allocated assigned to a T2. Okay, that is unsafe because as it leads to the unsafe state. So these are all the two algorithms for deadlock avoidance. Next, in the next video, we discuss the banker's algorithm.